3.5 billion years of research and development. So that is a lot of innovation and a long time for a family business to really start working. And so this whole family business has a fantastic economy that has developed during all that time. And from that economy, we can learn certain principles, ecological principles that we can apply. And one of these principles is that there is no waste in nature, that resources are very efficiently used, that in fact it's a circular economy. And that circular economy is something that we should go into, like energy use, for example, is from the sun. Diversity is at its basis. All life on Earth has diversity on its basis. Genetic diversity, species diversity, ecosystem diversity. And that diversity is like an insurance. It's like the possibility to adapt to changing situations. So nature functions as a community of interacting species, of cooperation, of not so nice biological warfare, a lot of that, dependency. And it's a robust system, it's a resilient system, but you know, it is something that this one species didn't understand quite well. About 200,000 years ago, this species came up and actually started its own economy. It sort of evolved a little bit away from this family firm of nature. And it started, in fact, as a sort of an invasive species, where it had an economy that was linear, and it was quite destructive. And this destructive economy is something that we now are dealing with. Resources are running out. We're having a lot of environmental adverse effects of what we're doing. About 10,000 years ago, Homo sapiens started with agriculture. And this agriculture was first based on a lot of diversity as nature functions, but it evolved away from that. It reduced diversity. It was focusing on maximum production only, to the adverse effect of, let's say, breaking through nutrient cycles. Actually, there was a lot that is really not what we want. And actually, agriculture is one of the major forces to drive the environment beyond its planetary boundaries at the moment. 38% of all land is used for agriculture, and we're expanding it into areas where we take nature away. So it's time for agriculture 2.0. An agriculture where we try to not only maximize production as one ecosystem service, but actually optimize the system and optimize all the other ecosystem services that nature provides, like the provisioning and the regulating services and the cultural services. And we have to go to system thinking, because the knowledge that we now have, we know that there are above, below ground interactions, that there are interactions between species of plants in their surroundings, and that the landscape structure is determining biotic interactions. For example, one of these wonderful biotic interactions that I love to study is the enemy of a plant, a parasitic insect that actually gives us natural control, already worth about $400 billion US a year. And if we don't shape our environment that these animals can function, then obviously we're losing that completely. We're now totally dependent with some of our crops on pesticides. And we all know that also pesticide use is actually inducing a next pest, because that third trophic level, these parasitoids and predators are very sensitive, even more sensitive to pesticides than our pest insects. A major challenge is the soil, and a major player in increasing the yields that we certainly have to do in the case of, let's say, organic farming, is the soil. The soil that has all these greatest biodiversity of, in fact, the whole world in the soil, and we know only very little of it. About 95% is still unknown to us. And what we now know is that there is a lot of intriguing things going on in the plant-soil interface with fantastic interactions between the whole microbe. It's not only in your guts, it's very important, but also in the soil it's very important. It actually has an intimate relationship with the plant. It helps the plants with nutrient uptake, resistance to pests and diseases. It helps the plants to trigger its immune system, and we can use that. And we have many, many new tools to find out what is in that soil and what it's actually doing. Molecular tools, chemical, analytical tools. In fact, we have fantastic tools agronomically to do our agriculture. Think of digital farming, precision farming. There's all kinds of new tools that we could use. So the challenge is to actually save our soil and preserve our soils. And of course there are many social, economic aspects to agriculture. More than 50% of all food is being produced by smallholder farmers. And in fact we need to have the challenge there to increase the yields, definitely, but also to preserve all these other ecosystem functions that we have, and also preserve the cultural differences that we have. Nature has a lot of variation that we can use, also in plant breeding. Variation that we should keep in the system and try also with the new tools in biotechnology to keep that natural variation and use that natural variation. I think we should try to close the gap between, on the one hand, let's say organic farming, and on the other hand, more conventional practices. We must find paths, in fact, to, on the one hand, maybe extensify the type of agriculture we have here in the West, and perhaps intensify with ecological principles the agriculture that we have on the organic side. And there's no time for dogmas, because we have the new generations to take care of. And in our economy, family firms are often the most successful. I think we're part of this big nature family firm. And we should therefore also think of these next generations, 9 billion to be fed. We need yield increases, and we're going to talk about that today.